Welcome to Cloud Dialogues. Don't forget to like and subscribe.
Hello again and welcome to Cloud Dialogues, the podcast for executives where we cover cloud-related topics. We've covered quite a few in the last 20 episodes, and this is episode 21, and we're going to talk about observability. And we are lucky to be joined by Boris Tane of Baselime. So welcome, Boris.
Thanks for inviting me.
So I kind of know Boris from the serverless space, really. In my research for this episode, I noticed that you have a master's in science in aeronautical, what is it?
Yeah,
aeronautical
Dynamics.
Yeah. Aerospace Dynamics.
Wow.
Tell us just a little brief bit about that.
Yeah, that was 2014, 2015. A lot of hype around that time around drones and autonomous aerial vehicles. I actually did my master's thesis on a drone. Essentially, it was mathematical modeling and machine learning modeling of a drone, such that you could predict how it will behave in scenarios that you cannot test in a wind tunnel or in a flight test. And it's really during that time that I started being really obsessed with data. The whole thing about the drone was collecting as much data as you could, such that you can use that data to build models and then use those models to predict what the drone will do. That's really what got me hooked onto becoming a data nerd.
Yeah. Well, you'd have to be, right, to be in it's all about data.
Yeah.
So you've done obviously a bunch of different roles in that time, and then you had a bit of entrepreneur flair. What made you start Baselime? Was there a particular moment, or did what you were working on sort of evolve into it?
Oh, so the story behind why I started Baselime is actually pretty simple. I worked at a few startups as a software engineer, and every time I will get into a company, at the time you wouldn't even call it observability, it was called monitoring. Their monitoring kind of scenario was pretty bad.
It always is.
Yeah, exactly. Like, prod is down, but people don't know why. People spend hours and hours going through dashboards and
This doesn't sound familiar at all.
George has heard this before.
Like, they're just pattern matching, trying to figure out what's going on. And me coming from a world where you fly this drone and you know everything about it in any scenario, to a world where it's a mobile application but you don't know what's going on, that was a bit insane to me. In those companies, I helped build the typical stuff like monitoring with Prometheus and Grafana, and your logs into Kibana, trying to get people to do structured logging, write JSON, don't write random strings, things like that. And after a while, I keep telling people to do the same things again and again. Why not make a solution that will make that easier for everybody out of the box, especially in serverless environments? Because the logic that most people have of dumping everything into a text file or into some database doesn't really work anymore, because anything that you do is in this, it's when the user is waiting for the response. So if a user clicks on a button in your app and then you have to send your logs to some place, they have to wait for you to send those logs before they get the response from that button click in a serverless environment. And that's not ideal. There are ways to avoid that, but a lot of the people that I had spoken to at the time were not using those techniques to avoid that. It just made everything more difficult. That's kind of the story behind Baselime. There were a lot of other ideas, like the concept of observability as code is something that I was quite passionate about. Observability without action is just storage, right? You can send as many logs and metrics and traces as you want. If you don't use those things, you're just paying for storage. Like, you're not getting any insights from it. The concept of observability as code, what if you generate all your alerts, your dashboards, your queries, your SLOs, everything as code, such that it's part of your development lifecycle, and then you don't have to go into a dashboard to click those things. A lot of providers today are also giving observability as code. If you're running your own observability stack in-house, there are ways to enable your developers to write some YAML or some CDK to generate those things. But what we learned during that time frame is that even observability as code is not enough. It's still work that you're asking developers to do, whereas the platform already knows a lot about your stack and should be surfacing those insights to you automatically rather than you having to create dashboards and alerts. And the first thing that we did in that direction was real-time error tracking based on your logs. So when developers will send us their logs, we will analyze quotation marks. It's not AI, it's a bunch of if statements. Hey, does this look like an error? And if it's an error and it's the first time that we see it, send a notification, an email or a Slack message to the developers. Do that within their existing observability stack. Don't ask them to install a new SDK or a new tool. That information is already in their logs. Most developers log their exceptions. You should be able to take those exceptions, surface, and send to the developers. So those are the ideas that we were exploring.
The hardest thing I find about monitoring, I'll say monitoring because that's what most organizations still do, right? They don't see observability as a separate thing. They see monitoring as let's build our dashboards and we're done. But what exactly should you be monitoring when you have an incident or something? There's always going to be some aspect of it that you're not capturing. So how does applying observability a lens to it, how can it solve that problem?
Yeah, so dashboards and common monitoring, let's call it that way, they are pictures of the past. So a dashboard tells me two things. Either somebody thought this will be a problem eventually in the future. Things like P90, latency, error rate. Somebody, when building the application or a few days or hours after building the application, thought, hey, we might have a problem with high latency. Let's have a dashboard to visualize high latency. Second thing is, this was a problem in the past. To make themselves feel good, the person created a dashboard for that. Garbage collection in a Node.js application, right? The application ran fine, and then one day it wasn't working. They figured out, oh, it's this problem. They solved it, and then they created a dashboard saying, hey, next time we have a problem, let's check this dashboard to make sure that it's not that same problem again. Those are the two things that dashboards tell you. Whereas in modern applications, you have emergent behavior, things that you couldn't potentially predict will happen ahead of time.
Therefore, they're not in the dashboard, yeah.
Exactly. They're not in the dashboard. So when those things happen, you end up in the situation where you're pattern matching. At the previous job, something similar happened. Could it be the same thing? And you're just guessing your way through to an answer. Whereas with observability, I think it's probably best to actually give a definition of observability first, because people get really confused and there's a lot of marketing materials out there that are just muddying the waters even more. I think the main idea is to be able to understand what is going on in your application right now without having to change your application beforehand. Like, you should have the tooling to be able to see something odd and understand why it's happening without guessing, without having to change your application and deploy it again. So it's one specific user with one specific set of configurations that are having that issue. If you need to go and deploy and wait for them again to do the same thing, you're probably never going to see it again, or you're not going to see it in the time frames that actually matter. So to have observability, to have that ability to understand your application, you need really two things. It's high cardinality and high dimensionality. So you need to be able to index data with as many fields as possible. So as many fields as possible literally means hundreds. Let's say you have an event, a log line, right? The log says user logged in, right? It should tell me which user it is, which location, server they are hitting, which git commit is this code from, when was when was it deployed, who deployed it, the headers of the request that they made, the response that we sent back, the body, the status code, all of those things should be in that event. It should be as many fields as you want. And the other thing is those fields should be able to take any random value. Like, you shouldn't be limited to only numbers or only, 500 different strings for user ID. It should be infinite. Like, I should be able to log the request ID of every single request coming into my application at 1 million requests per second, and that shouldn't blow up my database. And that's where the kind of current monitoring space is failing, because if you have those high cardinality fields, they then explode the cardinality and queries become extremely slow, or they completely toast the database anyways. To be able to understand what's going on in your application, you need those two things: high dimensionality and high cardinality, such that for every request you can send this giant object to your provider or your self-hosted thing. It's really good if you can self-host it. You should be able to ask questions. Hey, give me the count of unique user where the P90 latency was over 500 milliseconds, grouped by their location and the Git hash. And then you notice that this specific commit in New Zealand was impacting users and making them have latencies above this number. Then you can say why this commit specifically. You can now look at your code and notice that you have some weird time zone manipulation in there that is doing something specific for people that are in the New Zealand time zone. You're not going to be able to answer that question if you're using traditional monitoring tools. Now, a lot of people use OpenTelemetry for that. OpenTelemetry is awesome because it is kind of making the whole data collection, because to produce those high cardinality and high dimensionality events, you need some infrastructure. You need to have it in your code base to emit those events. OpenTelemetry makes it easy, but it's not mandatory. You don't have to completely buy into OpenTelemetry and have your entire application OpenTelemetry to have the sort of observability that we're talking about. And as a matter of fact, you can add OpenTelemetry to your entire application, but if all you're collecting is the default spans that OpenTelemetry emits, you're not going to be capturing your user ID. You're not going to be capturing your Git hash. You're not.
You've got to customize it.
Exactly. So the point is not, hey, let's install this library and have 2,000 OpenTelemetry collectors and call it a day. The goal is to have rich data that your application emits such that you can answer those questions afterwards.
It sounds like as well, Boris, like what you're saying there about, I think a lot of organizations are operating in this way, right? Where they've just got a series of dashboards and they're like, yes, we're doing observability. When you talk about giving the developer the right data, like a comprehensive data set at the right time so that they can understand what event has occurred, I feel like that is a developer experience issue, right? How do we give the developer the right data at the right time? Thinking about that person as an individual, as a customer even, like how do we give them what they need in order to resolve the problem?
Oh yeah, the main customers of Baselime were developers, people on the ground fighting for their app to stay up and resolving all those customer issues day in and day out. Depending on the size of the team, you can make the argument that the person kind of owning that observability piece is the SRE of the platform engineering team. But ultimately, I believe it's whoever built the application. By whoever built the application, I don't mean the individual specifically, I mean the team. If you have a team that built an application, they have the most context about that application. Ultimately, they are probably the best place to figure out exactly what is going on in that application. What I've been talking about so far is really application observability. There is also infrastructure observability, which is a tiny bit different. Let's take, for example, a database. To observe a database, you're not going to change the code of the database to start sending events every time something happens in that database. You still need to rely on those metrics, you should correlate those metrics with your application observability. So if there is a spike in error rates in your database, you're going to see that in the metrics of the database. You should then be able to correlate those metrics with the applications that are using the database. So if you have 4 teams reading and writing to the same database, and that database is experiencing high error rate, you should be able to correlate that time frame of error rate with what is happening in those 4 applications. Those 4 applications being instrumented in a way that is emitting high cardinality and dimensionality data. You should then be able to say it's not these other 3 applications, it's only this one that is making a query that is kind of infinite in complexity, and that's why the database is having those errors, and then spend a bit more time figuring out why that is happening. Now, if it's not the application the issue, if it's the database, that's where it gets a bit more interesting, because some databases now emit actually OpenTelemetry data that you can send to your provider. So there are 2 types of OpenTelemetry data. There's OpenTelemetry data that is as part of the application. Hey, you made a call, this was the span, this was the query, latency, etc. But there are also spans that are the internal spans of the database. So the database, let's take ClickHouse, for example, the database was doing merges at that point in time, or there was a lot of transfer between nodes. That data can also be exported to your observability provider. If your observability provider has an adapter for it, you can then have the same sort of high dimensionality and cardinality data for the database internals, rather than relying exclusively on the data from your applications.
That's pretty powerful, because historically you've had to go to the DBA team to do a dump during the time that the issue's happening. I've had to deal with that many times.
Yeah.
And you've got to capture the event at the time to be able to figure out what's going on. So it's kind of a new world compared to even 5 years ago, really.
Yeah.
If that data's being captured.
Yeah.
You said your customers are mostly sort of devs. Did they need to do much convincing of their higher-ups? Did you have to do much convincing of execs that it's worthwhile and teaching them why it's important?
Yeah, in the early days, I think when we were still figuring out exactly what we were building. But I think things started being a bit easier when 2 things. One, we figured out how to tell developers that, hey, we are giving you the ability to query your logs as if you're querying your database, right? Send JSON data and you will be able to do filters, aggregates, group bys, etc. on those fields in your logs as if you're querying your Postgres database. And the second thing was real-time error tracking, to be able to surface all of those insights to developers. So it took installing Baselime on a dev app that not a lot of people are using, and then starting getting those alerts and starting to be like, oh my, I didn't even know this application was doing this. I didn't even know this route was slow. I didn't even know if a user had this specific combination of input, the output would be this. And then the conversation became much easier with their higher ups, because it meant, hey, instead of spending a day or half a day trying to figure out why this thing is not working, we can just go into Baselime, click on 4 buttons and see exactly why. So the convincing was tough early on, but when the value was obvious, we were kind of bringing that value more to the foreground, and that became way easier.
That's always the hardest part, right? And I've found that the cloud providers have been a bit slow in the whole... I'm guessing that's partly why Cloudflare acquired you guys, right? To help them build on what they had.
Yeah, so we joined Cloudflare in April. What is interesting with the cloud providers is that cloud providers have different levels of, let's call it, maturity. So you have AWS that has been around for so long, and then you have the GCPs and the Azures that are a little behind, and then you have Cloudflare, and then you have all the kind of new players, the Vercels, the Netlifys, etc. And the kind of early cloud providers have the traditional monitoring aspect really locked in. People can make the argument that the developer experience is not great, using CloudWatch is not fun, but it works. It does what it's supposed to do. You have all your metrics about your Kinesis streams and your databases and all of that. Like, you have that with zero effort really on Amazon Web Services, and very similar story on GCP and Azure. Where it becomes interesting is the kind of newer providers, especially Cloudflare, where I'm at now. There are lessons that have been learned from the idea that logs, metrics, and traces are the three pillars of observability. We all know today that that is not true. There are no pillars. You need good data and a good query engine. Like, those are the two things that you need. Learning from those kind of insights from the early days of monitoring, we are building now that high dimensionality and high cardinality observability directly into the cloud platform. We are capturing logs and traces directly at the source, rather than having developers install 15 libraries to be able to capture those things. What is very interesting is that those learnings come from the work that all the observability startups and companies have done over the past 5 to 10 years, right? Companies, pioneers like Honeycomb, that really brought forward the idea that, hey, you can do better, right? You don't have to go through the pain of sifting through dashboards to understand what's going on. We learned from that at Baselime, and we improved on that kind of idea to surface insights a bit more automatically than asking developers to go and dig for them. And now those kind of newer cloud providers are also learning from all these insights to build observability directly within the cloud, rather than as a separate tool that is outside.
This all ties in with operating model as well, making sure that you have a well-established, I guess, like a really DevOps model in your organization. Because if you've got like different teams deploying applications to who are managing it, you're not going to get the sense of ownership over making sure that that data that they're receiving is actually being used to do something meaningful.
The technical core of observability is all the things I mentioned so far, but there is also the kind of team aspect of observability. You need strong ownership from the teams, because if you have all this data, you have all these insights that are surfaced automatically, but nobody cares, you're just storing data, you're not actually using it. So you need the teams to really own the entire life cycle of the application, from ideating and figuring out what to build and collaborating with PMs, to solving issues when customer support raises them, or when the SRE team says, hey, something is not right in your application. The application developer team should be highly involved to make sure that service and product they put out there is doing what it's supposed to do and serving their users as it's supposed to.
So I understand that we've got an old way of thinking about observability, like where, I'm assuming like looking for stuff we've experienced before. And then we've got a new way of thinking about observability, which is like putting the right data in the hands of the right people at the right time. And I know that there's like a bunch of tools that help us to do that, like Honeycomb. How do we make that transition from working in the old way to like working in a new way? Like, if we consider all of that data that that an app, like say something like Honeycomb, is capturing, like, how does it know what to look for? Is that a stupid question?
No, absolutely not. And I think
it is hard.
It's a very interesting challenge, because the quality of observability you get is directly correlated to the quality of data that your application produces, right?
Yes.
And if you tell the team, hey, I have this new shiny tool that is going to make you 10x, 100x better, but before you can use it, you need to rewrite your entire code base, the answer is going to be, bro, I don't have time for this. And we faced that at Baselime. Like, early on, we were, hey, you need to completely stop writing logs. Logs are so bad. You need to be doing X, Y, and Z. And it didn't get us anywhere. The tool that you're using that should make that transition as easy as possible. And the way we had been doing it at Baselime was, first of all, logs work, right? Even if you send string logs, you were doing machine learning to extract patterns from your logs and transform those string logs into high cardinality data. So your logs usually have a timestamp, usually have a log level, usually have a message, and in that message usually it's a common format. You're probably going to say something like user with ID X, Y, and Z just logged in. It's going to be the same thing 1 million times. The only thing that is different in the middle is that ID. Normally what you should log is a JSON, that is event user logged in. You put the user ID, email, you put the user email, and you add 100 other fields to it. Because right now, today, what you have is that log line. What we do is we take that log line, we transform it into a JSON object, and we enable you to still query it. Then you see the power of how you can query those 4 fields, and you're like, I want 10 fields, I want 50 fields, I want 100 fields. That's how we were able to get people through that kind of journey from I have crappy logs to I have high cardinality and dimensionality data. The other thing that is helpful also is dropping open telemetry that captures almost everything with the exception of your application specific data. So install this library, no config, no figuring out open telemetry collectors and blah blah blah. No, install this library, put this endpoint in it, deploy your application, you get tracing. Now they're able to query against status code, against path, against query parameters, against those things. And the next thing is, hey, I want my user IDs in there. I want my user emails in there. I want my card ID in there. I want my card price in there. They start then adding those manually. So it should be a let's hold the hands of those teams that are still using traditional logs and traditional metrics into the world where they have better observability rather than, hey, rewrite your entire application because you need to have this high cardinality data before you can do anything.
Yeah, that's pretty smart to transition. Try and make it as easy as possible. And that's actually good advice for our closing, really, for executives to question their teams around how efficient they are in debugging problems and are they doing it the most efficient way. It's all about education, right? Is there any top tips you recommend for organisations to try and move to that new way?
Yeah.
Things you've seen that have worked?
I think even before that, I also want to highlight that observability is not necessarily, hey, how do we debug issues faster, right? I think that's one slice of what you can do with observability. But observability is empowering your team actually to build a better product sometimes. Like, hey, send all of this data and then you can query it against any dimension. We have seen product managers using observability to figure out which features are used the most, which users are having a good experience, which users are not having a good experience. You essentially have all of this high quality data about how your application works into a place where you can slice and dice it against any dimension. That is extremely powerful. Now, in terms of tips, I think the main thing really is get into the habit of producing high quality data. And biggest issues I see and I've seen before is a log line that tells you there is a problem but not enough about the problem to actually figure out why the problem is happening. So something's wrong but you don't have the tooling to figure out what is wrong. Let's enrich those signals as much as possible. It doesn't have to be complicated. There are blog posts out there about how to do canonical log lines and wide events and all of that stuff to really get the high quality data as easy as possible.
I love the idea about the business metrics as well, because user experience is a big one. And I'm sure there's plenty of other business metrics that could be logged that other stakeholders would probably get advantage from. Cool. Thanks for coming on.
Thank you so much, Boris. We really appreciate it.
Especially on your week. And thank you, listeners, for tuning in. And
don't forget to like and subscribe.
And any topic ideas are always welcome.
Thanks for inviting me.
So thank you. See you all next time.